The binomial coefficients, often written as NCR, is the total number of ways of picking R unordered outcomes from n possibilities. Say we have 5 different objects A, B, C, D and E, and we need to find out the total number of ways in which 2 objects can be picked at random from these 5 objects. Example: BD, EA, CD, CB, etc. What is the total number of ways in which any 2 objects can be picked at random from these set of 5 objects? So this can be computed using the NCR, and NCR is computed as n factorial divided by n minus r factorial into r factorial. So if we come back to this example, the total number of ways in which any 2 objects can be picked at random from these 5 objects can be computed as 5C2, which is computed as 5 factorial divided by 5 minus 2, that is 3 factorial, into 2 factorial. This is equals to 5 into 4 into 3 factorial divided by, I can write 3 factorial into 2 factorial. So 3 factorial and 3 factorial gets cancelled, and 2 into 2 is 4. So the total number of ways is 10 different ways. So here is the overall idea to compute the binomial coefficient. In this algorithm, we need to find the binomial coefficient as n factorial divided by n minus r factorial into r factorial. The idea is to compute the value of n factorial and assign it to a variable x. We are going to compute n minus r factorial and assign it to a variable y, and then r factorial is assigned to a variable z. Then the final value of binomial coefficient is computed as x divided by y into z. That is exactly what we are going to do in our program. Initially, we are going to read the values of n and r. Then we are going to compute the value of x, y and z as n factorial, n minus r factorial and r factorial respectively. Finally, the value of binomial coefficient is computed as x divided by y into z. There are 2 important parts to this program. One thing is the computation of binomial coefficient. The second important part is finding the factorial of a number. If you consider finding the factorial of any given number, say 5 factorial, 5 factorial is computed as 5 into 4 into 3 into 2 into 1. So it is going to be the product starting from the number until you go on decrementing the number until it becomes 1. This kind of computation can be easily achieved using a for loop, and that is exactly what we are going to do.
Now let us just visualize the working of factorial of a given number. So here we have 3 variables: fact, number whose factorial we are going to find out. This is going to be computed later. This is the factorial of this given number. And then we are making use of the variable I in our for loop. So I have declared 3 different variables. And here is the for loop. The for loop extends from num till 1. So we are going to compute. We are going to loop through this for loop from the value of I equals to num till the value of I reaches 1. So during every iteration of the loop, we are going to decrement the value of I by 1. Inside the loop, the computation is fact equals to fact into I. So now let us see the execution of this program. Make sure that you have your eye on these values of the memory locations for fact and num. So initially the value of fact is set to 1, and we have already decided the number to be 5. So now we begin with execution of the for loop. For loop begins with the value of I equals to num. So the value of I is 5. It is greater than 1. So we enter the for loop. So fact is computed as the previous value of fact, that is 1 into I. So 1 into 5 is what is done next. So the value of fact is updated to 5. Next, the value of I is decremented by 1. The value of I becomes 4. It is still greater than 1, so it enters the loop. After it enters the loop, the value of fact is updated to the previous value of fact, that is 5 into the value of I. 5 into 4. So the value of fact now becomes 20. During the next iteration, the value of I is 3. It is greater than 1. So this goes on until the value of I is greater than 1. So during the next iteration, value of I is 2. 60 into 2, 120. The next iteration, the value of I is decremented to 1. Value of 1 is not greater than 1. Condition is false, so we simply quit the for loop and come to the next print statement, wherein we print the value of fact. So the value of factorial is 120. The value of 5 factorial is 120. This is how the algorithm for finding factorial of a number proceeds.
Here's a flowchart for a given program. Initially, we need to read the values of n and r, and then we have to compute the value of x, y, and z as n factorial, n minus r factorial, and r factorial respectively. Initially, we set the values of x, y, and z to 1. Then, using 3 for loops, we compute the value of n factorial, n minus r factorial, and r factorial. This for loops extends from the values of I equals to n to 1. So this is for the computation of x, that is n factorial. This extends from n to 1. We go on decrementing the values of I and we go on computing the product to get the value of n factorial. This loop goes on iterating as long as the value of I is greater than 1. As soon as the condition becomes false, we switch to the next for loop, which involves computation of n minus r factorial. So n minus r factorial loop extends from the value of I from n minus r until it reaches the value 1. So as long as this condition is true, we go on computing the value of y as the product of y into I. And next we compute the value of r factorial. Finally, we need to compute the value of BC as x divided by y into z, and then we need to print the value of BC. So this is the overall computation of the binomial coefficients.